Bismillahirrahmanirrahim. The amplitude V volts of a sinusoidal signal is a random variable with PMF. PV of V is equal to 1 over 7 when V is equal to minus 3, minus 2, minus 1, 0, 1, 2 or 3, and this is 0 otherwise. Let Y is equal to Y square over 2 watts denote the average power of the transmitted signal. Find the expected value of Y. So Y here is a derived random variable which is a function of this random variable, this discrete random variable V. So we can write that Y is a function of this random variable V like this, right? Some function of this random variable V. So we can find the expected value of this derived random variable in two ways. Either we can find the value directly using this PMF of the random variable V, or we can find the expected value of Y by first determining the PMF of Y, and then from the PMF we can determine the expected value of Y. So first let us find the expected value directly, right? So the expected value of derived random variable Y, for example, if Y is a derived random variable, so the expected value is also denoted like this, mu Y. This is given by this sum. So for all the values of V from its range SV, the this expected value is equal to the sum of these products. So GV multiplied by the probability, the corresponding probability of V at that value. So from the range of V, we pick a value and find this product. We find the corresponding probability and find the corresponding value of the derived random variable V, multiply them, and we repeat this process for all the values of V in its range, and then sum them together. So this will give us the expected value of Y. So for this function Y is equal to V square over 2, let's demonstrate this. So here expected value of Y is equal to, for example, we can take on these values. V is equal to minus 3, minus 2, minus 1, 0, 1, 2 and 3. So for each of these values we find the corresponding value of Y, right, and then we multiply it with the corresponding probability, which is 1 over 7 in each case. So V is equal to minus 3. So when V is equal to minus 3, Y is equal to V square over 2 is 9 over 2. So 9 over 2, right, multiplied by the corresponding probability, which is 1 over 7. Then plus the next value is minus 2. So minus 2 square. So this is 4 over 2 multiplied by 1 over 7. Then the next value is minus 1. So minus 1 over minus 1 square over 2. So that is 1 over 2 multiplied by the probability, which is 1 over 7, right? And then 0. So 0 is 0. So 0 multiplied by 1 over 7, and then again 1. So this is 1 over 2 multiplied by 1 over 7 plus 2. So that will be 4 over 2 multiplied by 1 over 7, and then 3, which is 9 over 2 multiplied by 1 over 7. So we now find the product, these products, and then sum them together. So this is 9 over 14, this, then this is 4 over 14, then this is 1 over 14, and here this is 0, right? Then we have again 1 over 14, then we have 4 over 14, and then we have again 9 over 14. So these are 1, 2, 3, 4, 5, 6 terms. We need to add them together, leaving out the 0. So the denominator is the same, so it will be convenient to add the just the numerator. So 9 plus 1 10 plus 4 14 15, and this is 9 over 14. This is let me just check. This is 9 over 14. This is 4 over 14. 1 over 14. This is 0. This is 1 over 14. This is 4 over 14, and again this is 9 over 14. So 9 and plus this is 9, right? This is not 1. So this is 9 plus 1 10 plus 4 14, and this is again 9 plus 1 10 plus 4 14. This is 28 over 14. So expected value of y, or mu y, is 28 over 14, which is 2. So the expected value of y, mu y, is 2. So we calculated this expected value directly. So alternatively, we can find out first the PMF of y and then calculate the expected value. So this is the indirect method. This is the direct approach. So first we find the PMF y. So for example, Py of y, let us calculate the PMF. For example, we can take on -3, right? And the corresponding value of y is then 9 over 2, right? 3 squared is 9, 9 over 2. And for this 3 also, this is 9 over 2. For both these 3, this is 9 over 2. And for each of these 3, the probability is 1 over 7. So for both these 3's, the corresponding value will be 2 over 7. So the probability is 2 over 7 when v is equal to 9 over 2. Again, we can take on -2 and 2, and for each of these these values, the corresponding value of y will be 4 over 2, which is just 2. So for this 2 also, the probability is 1 over 7 plus 1 over 7, 2 over 7, right? And then again, we can take on either -1 and 1, and in both the cases, the value of y will be 1 over 2, and the corresponding will be probability for 1 over 2 will be 2 over 7, right? So because 1 over 7 for this plus 1 over 7 for this will be 2 over 7. However, for when v is equal to 0, right? So then y is also equal to 0. Sorry, this should be y here. So when y is equal to 0, the probability is just 1 over 7, and this is 0 otherwise. So from here also we can calculate the probability, the expected the expected value of y. The expected value of y, or mu y, in this case is just given by this sum. We take out all the values of y from its range, and for each value we calculate this product y, the value of y, the random variable y, and its corresponding probability, and then we sum these values together. So what we do is we take on the value of y and multiply it with its corresponding probability. We take the value of y and multiply it with its corresponding probability, and we repeat this process and then sum all these values together, right? So for example, here in this case, so this is the expected value of y is 9 over 2 multiplied by 2 over 7. So 9 over 2 multiplied by 2 over 7, then 2 multiplied by 2 over 7 plus 2 multiplied by 2 over 7, then 1 over 2 multiplied by 2 over 7, and then 0 multiplied by 1 over 7. So the expected value of y, mu y, we need to sum these values together. So so this is this cancels out, right? So this is 9 over 7, right? Then this is 4 over 7, and this is again, this 2 cancels out with this is 1 over 7 plus 1 over 7. So the denominator is the same, 7. So 9 plus 1, 10 plus 4, 14 over 7. So again, the expected value of y is 14 over 7, which is 2, which is the same answer that we obtained here. But this value was obtained directly without calculating the PMF of the random variable y, right? Using this procedure. However, we obtained the expected value by first determining the probability mass function of y, of the derived random variable y, and then we found out the expected value in the normal manner.